Let's begin with a fundamental question about understanding the birth, direction, and ultimate end of time. What is time? Did it exist before the Big Bang? And when the universe meets its end, will time cease to exist as well? Like the universe itself, time is an ancient concept that humanity has long tried to comprehend. But is time a phenomenon that flows independently of everything and everyone, like a straight line? According to classical philosophy and pioneers of physics such as Galileo and Newton, the answer to this question is yes. Isaac Newton believed that time was fixed, universal, and absolute. In his view, time was a reality independent of space and would continue to exist even if nothing else in the universe remained. Much like Shakespeare's metaphor that all the world's a stage, Newton saw time as the one constant element on the stage. However, Newton's laws were not flawless. The orbital motion of Mercury remained a problem that his physics could not fully explain. While Newton attributed this discrepancy to the hand of God, the scientific community sought a deeper explanation. The man who completed the picture Newton left unfinished was a young genius working at a patent office, Albert Einstein. In 1905, Einstein published his theory of special relativity, which dismantled Newton's concept of absolute time. According to Einstein, the only constant in the universe was the speed of light. This revelation showed that time was not absolute but relative. Einstein explained his theory through a thought experiment. Imagine a fast-moving train. A person standing beside the train sees two lightning strikes hitting two trees at the same time. However, for a passenger on the train, one lightning strike appears to hit before the other. This difference is a striking demonstration of the relativity of time. With his legendary equation E equals mc, Einstein explained the relationship between energy and mass. This equation revolutionized the way we perceive time and space. As an object accelerates, its energy increases, and consequently its mass grows. As it approaches the speed of light, time slows down to such an extent that even a second feels infinite. This is why it's impossible to exceed the speed of light. To better grasp this concept, let's examine the famous twin paradox. Imagine two twins, Jesse and John. Jesse embarks on a one-year journey in a spaceship traveling close to the speed of light, while John remains on Earth. When Ace returns, she is only 31 years old, whereas John is 81. Time had slowed down for Jesse due to her high speed. Einstein demonstrated that time is not an absolute concept, but one that changes depending on motion and speed. This became a cornerstone of modern physics. But what about the end of time? The question of what happens to time at the end of the universe remains a mystery for scientists. Perhaps the end of time will be defined by how we perceive it.